podcast. Get ready for an exciting journey as we explore the latest and greatest in innovative technologies, open source tools, and visionary insights. We'll take you on a captivating adventure as we uncover stories, discuss ideas, and connect with leaders changing the game and shaping our digital future. So sit back, relax, and get ready to be inspired.
All right, welcome everyone to another episode of Quenby Podcast. We got the coffee ready, we got our guests ready, and today it's gonna be fun. It's gonna be fun because I'm gonna let you know that it's gonna be technical. We had a lot of stuff here, pretty cool. Today, Jhon, which is our guest today, is gonna bring us a lot of knowledge about how to manage properly autoscaling in Kubernetes. And something that I like about his talk is gonna be there's no one size fits all. That's something very interesting because that's what we usually hear out there, oh, we got this and this solves your problems. Usually it doesn't happen like that. So Jhon is a Ph.D. on applied mathematics. So buckle up, guys, because it's gonna be interesting. But at the same time, he's gonna explain to everyone how we're gonna deal with this amazing world of Kubernetes and autoscaling. So Jhon, welcome. How are you doing?
Great. Thanks for having me, Angel.
Of course. And something that I want to share with the audience before we dive into your presentation is we met at KCD Texas, where we had that interaction. We had a lot of conversation that was pretty fun. When we dive into a lot of stuff, we talk about math, then we talk about AI, Kubernetes, and we end up basically with hours of talking on different topics, but all of them related. And it seems like what you're doing currently as StormForge as a CTO is applying all of that, right? So before we get into the topic, can you just give us a brief intro about you so the audience can get to know you?
Yeah, sure. So as you said, I'm the CTO of StormForge. My background is applied math, so I sort of specialize in machine learning, but as CTO, I also do a lot on the sort of product management, working with customers, working with the community, hence how we met at KCD Texas. And StormForge, we use machine learning to right-size containers running on Kubernetes. So the vertical autoscaling part of running Kubernetes, but obviously, as you said, it's not a one-size-fits-all proposition. So we've working with customers for years now, seen a variety of the other sort of tools, challenges people run into, and thought just an overview would be interesting.
And I know from firsthand that that's a passion that you have about optimizing and really get it right. So how this passion came basically up, how it was growing into you, this passion about optimizing workloads in Kubernetes?
Personal experience. So when we were very small, we were using machine learning for another application in a different product. And we were running the backend on Kubernetes. And as everyone knows, running machine learning can be extremely expensive. So our boss was endlessly being can we make this a little bit cheaper without making the performance go down? And so we spent a huge amount of time doing it manually. Going in, we have various sort of levers we could pull: requests, limits, batch size for training the models, and we would tweak all of them manually. And after doing that for a week, we quickly realized it was a terrible job. Nobody wants to do it. And B, it's a job which is perfect for machine learning. So it was sort of, we lived the pain and then realized that machine learning was the perfect solution to the problem.
Yeah, and I like that. I like that you share it because autoscaling in Kubernetes, it seems simple as autoscaling. Great, yes, it goes up and down based on the workload. But when you actually get into the nitty gritty of Kubernetes and how it works, not everyone really understands it. And even if you get to understand it, it's hard to get it right. So we were talking about that in Texas. So I know that you have a presentation that you want to share and kind of get us right into how you understood this problem, how you get to compare even to multiple solutions. So please go ahead and get us into the roller coaster of autoscaling, the real autoscaling.
I don't want to would kill people with slides, but I have a few. And the main one I like to bring up is this one. And I think it highlights very nicely the three different dimensions people need to think about when they're doing autoscaling. So there's horizontal, so that's how you scale a workload up and down, add and remove replicas as the load on an application increases. Vertical, which is how you size each of those correctly. And horizontal and vertical, these are not new concepts. These have been around for a long time, pre-containers. AWS has had auto-scaling groups for a long time. And the vertical sizing, people have been doing this for a long time with VMs, just deciding, do I need a T2 medium, a C6 extra large? What size and shape VM do I need? So very familiar. With Kubernetes, you can see at the top, there's one extra dimension, which is cluster autoscaling. And then this is how you want to share resources between pods in your cluster. How do you have the right nodes to run pods at a given time? So three different dimensions, each for slightly different use cases. And then there's a variety of tools. For the horizontal side, there's the HPA, the horizontal pod autoscaler built into Kubernetes, been around since basically the beginning. Then there's a slightly more advanced project, the Kubernetes event-driven autoscaler, which has a bunch of nice functionalities to make it easier to have a bunch of basically pre-configured, pre-built scalers for different common use cases. On the vertical side, there's the vertical pod autoscaler, or VPA, which is less used. And then StormForge, my company, is a replacement for this. So it uses machine learning and automation to right-size pods on an ongoing basis. And then finally, on the cluster side, you have the cluster autoscaler, which has again been around since the beginning of Kubernetes. And then a new tool, Carpenter, open source by AWS a few years ago, which we've seen getting a lot of traction in the community. And a lot of people are excited because it lets them run their clusters more efficiently, leverage spot instances, etc. So I think that's part of the reason there's so much confusion, because it's not a single one-size-fits-all problem, and there's, for each given dimension, lots of tools out there.
Yeah, and I love this slide, by the way. It's because if I'm kind of like portraying this correctly, so when we're working with the horizontal autoscaling, right? It's primarily based on like, okay, so how many replicas do I need, right? Based on usually, actually by default, if I'm not mistaken, please correct me if I'm wrong. By default, it's based on CPU and memory, but you can also do it by all the type of metrics, but you have to do some configuration to get them right. So how many replicas do I need? But then when you're talking about the vertical autoscaling, is it kind of more like understanding your workload and then saying, okay, initially you said that you need this pod to be, 200 milli CPU and 120 gig of RAM, megabyte RAM. But now I'm suggesting that it should be either more or less based on historical, and that's why I definitely agree with you. Like, machine learning can do a better job than us. But like, how you guys got to that? Like, how you realize that? Or I don't know if you're gonna get into the more details about that part or the others.
So why don't we start with horizontal? Just because when people start with autoscaling, that's typically where they start.
Perfect.
Horizontal or cluster, because there's two reasons you want to do autoscaling. One is performance and reliability. You want to add resources as the traffic goes up and make sure that you have enough pods and nodes to handle the traffic. And then on the other side, it's cost. You want to make sure you pull those resources down and aren't wasting resources for no reason. And everyone knows if you have to choose performance versus cost, what do you pick? You pick reliability, of course, because it's better to be reliable and expensive than unreliable and cheap, which is why everyone starts with horizontal and cluster autoscaling. And then the HPA, as you said, the default is CPU utilization. And in the first version of the HPA, released many years ago, the only available option was to scale on CPU utilization. It was the only option. And then quickly they realized that was a little bit restrictive, and often CPU utilization isn't a great metric to scale on. And we've seen people struggle with this all the time. Imagine you have something which is very bursty, or something which does a lot of network access. So the pods will be sort of still like under load, but maybe the CPU will be idle for a little bit of time, you can find that you're constantly flapping. You're adding replicas when you don't need them, you're taking them down when you shouldn't be, and then scaling on custom metrics. It has been found to be a more effective strategy. So we have a customer we work with. They found that they were endlessly adding and removing replicas every minute or so. And then when they switched to a more reliable custom metric, which represented basically the number of in-flight requests app was working on, plus the number of like available capacity, it was much cheaper, more stable, more reliable, etc.
Yeah, and to your point, I agree with you, because it could be also the language that is being written influence that, because you could have like, and this is not like about like a language word, but it's facts, right? But there might be some languages that are more based on memory than CPU, but that doesn't mean actually that the workload is being under pressure. It's just because the language consumes more, right?
100%, exactly. Which is why the second version of the HPA had so much extra flexibility. You can expose Prometheus metrics on your pods. You can pull in external metrics from something like Datadog, and you have all this extra flexibility. However, the classic story with Kubernetes, along with all that flexibility, comes a lot of complexity, and that's where KDub comes in. Rather than everyone do all of their own plumbing, it provides out-of-the-box pre-configured options. For the major cloud providers, you want to scale on AWS SQS, you can scale on QDepth, you want to scale on RabbitMQ, Kafka, all sorts of options. And then they also provide a lot of the other tools you need for the plumbing. For example, the ability to authenticate to these providers so you can actually access the metrics, etc. So it's all of the functionality provided by the HPA, but with just a wrapper on top, which makes it easier for people to get up and running.
Okay, so now that kind of on the getting into the before we get into the autoscaler for the cluster, let's say from the business standpoint, because we also have audience that are less technical but more business oriented, like what would this represent to them? Like how they should see the horizontal autoscaler in terms of business?
So the whole point of moving to the cloud is you want to be able to rent resources when you need them and then turn them off when you don't, and use that elasticity of the cloud. So imagine you have a business which has sort of a financial, let's say it's some sort of financial application, and it requires a lot of processing 9 to 5 during the week. But outside of that, 60% of the week, you don't need basically anything. You would like to run that in the cloud because then you pay 9 to 5 during the week, but you don't on the weekend. So the whole point and the sort of reason to use the cloud is the elasticity, and that you can pay for capacity when you need it and not when you don't. That's exactly what autoscaling and the HPA is going to let you do. It's going to let you scale up when you need it, and most importantly, scale down when you don't. So,
and I believe that's what basically kind of like summarizing what you said before. Like you don't just have to throw money at the issue. Like you can actually be smart with the money and make sure that it's only spent where it's needed, right?
Exactly. And what we find is that when it comes to Kubernetes, people typically are not smart. I think cost optimization is not a day one problem. First, you have to sort of migrate security, CI/CD, etc. And cost optimization is not a day one problem. So people just over provision, they just throw resources at it, and that works until you actually get to scale, and then it can become very hard to dial it back, which is why I think the FinOps Foundation did a survey recently, last year maybe. They found that something like 70% of resources in a Kubernetes cluster are just wasted, which is wild, because if you think about what people are paying for their cloud builds, if they could cut that in half, that would be great.
Oh, especially, I mean, and I think this especially on, I don't want to say all of them, but most of the startups, when they start throwing the money at the problem because, oh, I got credits. Great.
Exactly.
So they rely on that. So have you experienced that with customers, or is it something that you've seen before? Like, yeah, I just got credit, so I don't worry about that. And then they figure it out. Oops, and now I need to pay. We
don't see as many startups. We work with some, but I mean, you work for a startup, you know that the main thing is growth, stability, shipping new features, etc. But larger enterprises where the cloud bills can be extremely large, I think it comes down to you migrate to Kubernetes. That's a difficult migration. You want to make sure it's successful and you're not doing any sort of premature optimization. It's just if you leave it too late, it can become unbelievably expensive and hard to unwind. That's what we see a lot of.
Okay.
And to go back to the various dimensions of autoscaling, we talked about horizontal. The main driver of that waste is people who get vertical autoscaling wrong. So with Kubernetes, when you go to run a container, you have to set requests and limits. And requests and limits say how much CPU and memory does this pod need. And if you request one core, but you only use 100 millicores, you still pay for the one core. So in this case, 90% of it would be waste. And the same survey from the FinOps Foundation, they found that I think 70% of the waste in Kubernetes, the majority of the waste, comes from people over provisioning their pods. Which is, it seems on the sort of, if it's such a simple, obvious problem, the question is then why don't people get it right? And it just comes down to, it's too painful. Imagine you're running thousands of workloads in a cluster. You can't get thousands of different development teams to go in every week and pick the right resources. Maybe they don't have the tooling from the platform team. Maybe they don't have the right incentives because they care more about new features, reliability, etc. Maybe it's just a time thing where it will just take more time. It will cost more in engineering time than it will save in cloud costs. But no one ever manages to do it manually, which is where StormForge comes in. The only way to solve this at scale is with automation. And then the key part of the automation is knowing the right values to set, which is where the machine learning comes in.
Oh, I got it. So basically, right. So before we dive deeper on the bit on the autoscaling for vertical autoscaling, so it's more about like, because of my, let's say, wrongdoing on setting my requests and limits for my workloads, my horizontal core is always going to add more replicas, but doesn't mean that necessarily I need all those replicas. And I'm going to put an example and see if this actually, I got it. So let's say I have a workload and I grow from 1 to 20, but I have one core of CPU requested and let's say 1 gigabyte of RAM requested. But in reality, my application is not using that much. So because I'm never coming back and fix that, maybe my application is always on almost 10 replicas when it should be more like 5, but with less resources. Am I getting that right?
Very close, very close. I think the key point is that if you're adding and removing replicas, if every replica is 5 times larger than it needs to be, adding and removing them doesn't help if all of them are inefficient. So it's that even if you're going up and down dynamically, you still have to size each of them correctly or it would be very wasteful.
Okay. All right. See, and that could also trigger the cluster autoscaling, which we haven't got that yet, but it could trigger more cluster autoscaling, which my understanding, those might take a little longer to go up and down because it's an actual machine that you're spinning up, even if it's a virtual machine. So can you help me close that loop in a way?
Exactly. Perfect. Yeah, perfect. So that's exactly how it works. What happens? So the way cluster autoscaler Carpenter works is the HPA is adding pods, and then each of the pods, the Kubernetes scheduler will go in and try and find a node to run it on. And one of the key sort of things the scheduler is looking for is there a node with enough empty space to schedule and accommodate a pod of this size? And then eventually you run out of capacity, especially if you've over-provisioned every single pod. You run out of capacity, and then you get pods which are unschedulable, just because there's not enough resources left in the cluster. So the cluster autoscaler and Carpenter are both constantly watching the Kubernetes API to see if there are unschedulable pods. And then when there are, they will spin up new nodes which will run those pods. And then, as everyone knows, with Kubernetes, you pay for the nodes. So you pay for the nodes. So the way it all comes together is the HPA is adding replicas. These replicas are not sized right, so they're very inefficient. You run out of capacity, and then you add way more nodes than you actually need, and your bill is 3 times larger than it should be.
Oh, okay. So is it safe to assume from the business standpoint that it's going to be cheaper for me to make sure that my vertical autoscaling and my horizontal autoscaling are good, so I don't have to pay for the big one, which is the cluster autoscaler, which usually is the most expensive one, right? Is it safe to assume something like that?
I would say they all come together, but you need to make sure each of them is coming together. You need to make sure that you're adding and removing replicas at the right time, scaling on the right metrics. As you're adding and removing those replicas, you need to make sure that you have the right, you need to make sure that you have the right size replicas, the right size pods. And then when you're adding nodes, you also need to make sure that you're adding the right type, like shape, size nodes. Because imagine you have a lot of pods which are very CPU heavy. If you end up running those on memory heavy nodes, you'll only be able to fit a very small number of them, and you'll waste the vast majority of the resources on that node. And the reason and the fix is obviously, okay, you need to say, okay, for these pods which are CPU heavy, run them on CPU heavy nodes, and these pods which are memory heavy, run them on memory heavy nodes, which is where the cluster autoscaler and Carpenter comes in. And this is one of the big advantages Carpenter has. It does a much better job of picking the nodes, letting people basically use a wide variety of nodes so that you can get the right pods running on the right nodes.
So, I mean, in a way, can you give us maybe more like a financial example? Like, okay, how much can we really save by doing all these, right size metrics and that? Like, do you have like some sort of like a ballpark or an idea, an example that you can kind of like share?
I can use high-level numbers from people we've worked with. Typically, the savings from just right-sizing pods, you can save 50% of the resources, which translates to 50% a cluster, which is 50% smaller. If you then go in and use Carpenter to consolidate, there's typically another sort of 25% savings in there, because the average efficiency of a Kubernetes cluster is only like 25%. So there's a huge opportunity here. The bulk of the savings are on the vertical side, sizing the pods, but Carpenter also has the automation to constantly garbage collect, turn off nodes which aren't necessary, etc., and stop the cluster becoming fragmented. And then so that's all on the usage side, how you can reduce the usage. The other thing Carpenter does an extremely nice job of is letting people run workloads on Kubernetes on spot instances. And the reason for that is the cluster autoscaler, typically the way it works is you set up a bunch of autoscaling groups for various different instance types in AWS. And then when you need to schedule a pod, the cluster autoscaler picks between all of those different options, tells them to add a VM, then the autoscaling group adds the VM, and there's like it's an extra hop. And typically what that means is it takes 2 or 3 minutes to start a new node when you need it. So Carpenter eliminates all of the cluster or the autoscaling groups, and it talks directly to the EC2 API. And what this means is it can start machines much, much faster. So what we found is when we run Carpenter on the back end, we also run Cater on the back end, we run StormForge on the back end. When we moved to Carpenter, we found that the time it took us to start a node dropped from 3 minutes to just over a minute. And when you're running spot instances, it's amazing. Carpenter's the best. We love it. It's amazing. So when you're using spot instances, you get given a 2-minute warning that you are going to be interrupted, which means if you can start a new node and reschedule it in a minute, that means you can use spot instances with no risk of disruption, which is amazing because spot instances, depending what you're using, can be extremely cheap compared to on-demand prices.
Okay, so let me try to put this in kind of like summary, because what you're saying is a lot of saving right there, because I'm doing my math in my brain, and I don't have an applied mathematics like you, but I can kind of put together some numbers and say, like, I'm a company and I'm spending 10 million a year in cloud spend Kubernetes, which is not insane. It's actually, I consider, like kind of
surprisingly common.
Yeah, so middle to small size. So there's a metric that you shared at the beginning, which is about 70% of the cloud resources on Kubernetes is being wasted, which is true. I've seen it. A lot of people
it's everywhere. It's everywhere.
It is like that. So So let's assume that based on all these, we really can save those 50%. So that's basically like 5 million right there that we just burning.
Oh, more. Yeah,
Oh,
because that's just on the over provisioned workloads. If you were to bring in the consolidation, the smaller clusters, the more efficiently packed nodes, plus spot instances, it could be 7 or 8 million. There's a huge potential savings there.
And we're talking about I don't know the numbers by heart, but we're talking about this like almost a $1 trillion market, pretty easy.
That's a number I haven't seen as often. But yeah, no, the cloud providers have huge customers, and like the amount being spent on the cloud is huge. So yeah, your number's probably not too far off.
Yeah. So okay. So now, doing one step back, just because you've been mentioning a couple of things that I want to like kind of get some clarity out of it. Like you mentioned multiple times FinOps. Would you mind kind of like give an idea like what really means FinOps?
Yeah, sure. That's perfect. That's a great question. So you remember DevOps, and the whole idea was to bring developers and operations people closer together, so it was easier to ship things, track what was going out, support applications, etc., rather than just throwing it over the wall once every 2 weeks at the end of a sprint. So FinOps is the exact same idea, but for managing cloud costs. And now the goal is to bring together the finance people who understand the financial models, purchasing, things like if you buy a reserved instance upfront for 3 years with partial payment, how do you amortize that? How do you share out shared costs? Things like that. So bringing together the finance people with the engineers who maybe have a little less familiar with the numbers, but understand in detail how the system works, and basically enabling everyone to run sensibly, efficiently, with real visibility in the cloud. And I'm sure you've heard of it, but it's like Kubernetes, where 6 or 7 years ago, a lot of enterprises were like exploring it. FinOps, I think, was the same. Now it's everywhere. And it has to be, because it's reckless to spend hundreds of millions of dollars in the cloud without really knowing how it's being spent or how efficiently you're using that money.
Yeah, and yeah, absolutely. And with the numbers that you really share, like definitely you have to think about it. So now let me see, in terms of like Computer, in terms of the StormForge and Keda, can we consider them tools within the FinOps realm, or is something else?
I would say they're definitely sort of part of it. So the typical FinOps cycle, you see the graphic a lot, the 3 stages of FinOps. The first one is the informed stage, so just understanding what you're spending. So that'll be things like making sure all of your resources are tagged, and that you have reports saying, okay, I'm spending this on non-prod, this on prod, this on Kubernetes, this on RDS, etc. And having the ability to track all of that over time. So that would be the informed stage. The second is the optimized stage. So in the optimized stage, it comes into, okay, I know what I'm spending. In the optimized stage, how do I actually reduce that? And typically they separate it into 2 types of optimization. There's usage optimization, which is a great way to spend less money, is to use fewer resources. And then there's rate optimization, which is things like reserved instances, spot instances, which are, okay, I'm going to use the same amount of CPUs, gigabytes of RAM, but I will pay less for them because I will use reserved instances, spot instances, etc. So Keda, Carpenter, StormForge would all fall into the sort of usage optimization, how to just auto scale up and down, add resources dynamically so that you're running efficiently at all times. Okay. And then the final stage of the FinOps cycle is operate, which is the automation and processes to do all of this on a continuous, regular basis.
Okay, so I wanna get in a little bit more into StormForge and understand it. But before we do that, you said I love Carpenter. Can you kind of like give a little more description about what Carpenter does, what really means, and how people should see it?
Yeah, sure. Carpenter is a replacement for the cluster autoscaler. So it's going to watch for unschedulable pods and add nodes when it needs them. That's the sort of what it's doing on the way up. And then it's constantly watching to see if you have the ability to turn nodes off. And the big difference on the second part is, and so what's great about the first part is it breaks the sort of one-size-fits-all model of the cluster autoscaler, where you have an autoscaling group for T2 mediums, an autoscaling group for T2 larges, etc. And what it does instead is it just lets you define what attributes of nodes you're comfortable with. So you can say, I'm fine with anything from a C, an M, or an R family, anything between a 2x large and an 8x large. It can be on-demand or spot. It basically gives you much more flexibility to specify what nodes you need, and then it will make the intelligent choice for you to be like, okay, right, on Mondays we have a lot of compute-heavy pods. On Mondays we'll run a lot of compute-heavy nodes. On Tuesdays it's something different, and it will just constantly consolidate on an ongoing basis. And the big difference it has with the cluster autoscaler is the cluster autoscaler looks for inefficient nodes at an individual node level. So you can set a utilization percentage, which once it gets below, that node will be turned off and those pods will be reassigned. So imagine you're running 100 nodes and that utilization threshold is about 60%. Each of those nodes can have 40% waste and they will stick around, which adds up to a lot. Yep. Carpenter is more intelligent and will say, okay, I can turn off 30% of these nodes and I'll be able to reassign those pods, and then all of the nodes will be 90% utilization. So the fact that we'll do this sort of multi-node consolidation is huge. And then the ability to use, it picks the right instances for you, it consolidates on an ongoing basis. And then the spot instances, it makes it so much easier to work with them, which again is a great way to save money. And when it comes to things like spot instances and autoscaling in general, it always comes down to risk versus reward. Like we were talking about at the start, it's balancing performance and reliability with cost optimization and efficiency. And how you want to strike that balance varies within a company. What we see a lot of people do is when they start with these autoscaling tools, they start with them in non-production environments because the potential savings are typically huge because they're often lightly trafficked. And the risk is also much lower because it's not production. So we see people, they'll do things, they'll test out spot instances, they'll try StormForge, automating the right sizing in non-prod, and then eventually get to production. But yeah, Carpenter's, it's fantastic. It's just extremely high quality. It's really easy to work with. It's really responsive, and it's just, there's not many tools which will save you 30% on an ongoing basis.
And actually, I agree with you in something that you just said that, and I did found this in multiple setups where most of the waste is on the actual non-production environments because
100%.
I forgot that these numbers.
It's another dirty secret, along with how inefficient Kubernetes clusters can be. Another one is that typically you can save a huge amount of money and bank quick wins very quickly by looking at non-production because it's much lower risk and it's potentially a lot of the value.
Yep. Yeah. Oops, I forgot I got 3 environments. Oh,
exactly.
There you go.
Yeah, exactly.
And so about Carpenter, is it work in multiple cloud or is primary AWS? I'm not too familiar with it.
Amazing question. So it was created by AWS, but they open sourced it. And to open source it, donate it to the CNCF. It can't be cloud provider specific because then it wouldn't really be proper open source. So the way it works is there is a core Carpenter which does things like the consolidation, picking the nodes, watching unschedulable pods, etc. And then that is sort of Carpenter core, and then it has a provider model where you can have, okay, this is the AWS provider, this is the Azure provider. So that's how it was architected. Initially, the only provider was for AWS, but last year at KubeCon, so almost 12 months ago, Azure launched support for it. So right now it's available in Azure and AWS. I don't know what the plans are for other providers, but I'm sure they'll be welcomed.
Oh, absolutely, yeah. I think that something very similar happened with OpenCost, which is started with like just few providers and now have like, at least the last time I checked, it was like about 10 providers already built in.
Exactly, yeah, 100%. It's exactly the same. Exactly the same sort of strategy.
Got it. So now let's get into StormForge, because I believe you also have some sort of like a quick demo that you can show us how it works.
Yeah, sure, I can do a demo. 1 second.
Yeah.
Sorry, 1 second. Let me share my screen. So StormForge is a tool. It effectively replaces the VPA to help you right-size your pods at scale. And anytime you're working with hundreds, thousands of environments, the key is around automation and ease of use. So just making it as easy as possible to save money. The way it works is you Helm install an agent into your cluster. We pull all of the data, so we automatically discover all the workloads in the cluster. We pull all of the data out of Kubernetes. It's all in standard endpoints like cAdvisor, etc. And then you see something like this. And what this shows you is what you're currently using, what we recommend, how much you could save for CPU, memory, and cost. And then you can break it out a little bit further, and you can see how much of that is coming from over-provisioned workloads and how much of it is from under-provisioned workloads. And this gets talked about, the under-provisioned workloads gets talked about a little bit less, just because most workloads are over-provisioned. But it's more important because, as I said before, it's better to be over-provisioned, reliable, and expensive rather than under-provisioned and unreliable.
Yeah.
So we've actually, when you think of it, we would say it's all about right sizing. And we actually have found that people using StormForge see fewer reliability issues due to resource contention on clusters using StormForge because they don't have under-provisioned workloads. So this is the overview. You can break it down by cluster, namespace. You can separate out over and unprovisioned workloads. And then, so you install, and then the question is, okay, what sort of recommendations does the machine learning think, or what sort of recommendations is the machine learning making? So the way it typically works is you come in, you can see what you're using, different percentiles, and then what we recommend. And I've disabled the current just because this is the common scenario. You were requesting 500 millicores, and then you only need 5. So the way customers typically test is they'll come in, they'll install the agent, and they'll leave it a week or two and see what sort of recommendations StormForge makes. And then once they trust them, they realize that the values are better than the ones that developers picked semi-randomly a year ago and forgot to revisit. They then talk about, okay, how do we actually take this into production? So then we have, we're based around patches. And so you'll get a patch, and the patch will contain CPU and memory requests and limits. And there's basically 2 ways to work with the patches. So we have the initial agent I mentioned is read-only. So you put it in, all it can do is see the data, but it can't actually do anything. We have a second component called the applier, which will then patch on an ongoing basis and let you automate the problem. So you can install our component, which will automatically patch, or if you have security concerns, you don't want something which has write access in the cluster, you have a complex deployment pipeline, you can do whatever you like with the patches. So it's the balance of a happy path, which is easy to use, plus the flexibility to do whatever you like. And so the other concern which comes up frequently is, okay, I also need to configure the machine learning to do what I want it to do. And we provide a variety of levers here. So the first is you can pick your optimization goals. So for every single workload, you can pick between savings, balance, and reliability. Savings will focus on maximizing the amount of waste which is eliminated, but now and then a workload might be unprovisioned for a short period of time. Reliability will save less money, but will be extremely careful to make sure that there's no chance of the usage going above the CPU requests. So that's the goal of the machine learning. You can control the schedule. We recommend daily. And what's great about this is it means the amount of churn it introduces to the cluster is very low. We make a patch once a day. People typically do something at like sometime around 2 a.m., just when there's less people using whatever software they're hosting. So you set the schedule, and then you can set if you want to deploy automatically. If you don't, initially you'll just have to manually click. But over time, people typically become comfortable with the product and they turn on automatic mode. And we have people automatically right-sizing tens of thousands of workloads every single day. But again, it gives you the ability to sort of dip the toe into the automation, see what it would do without having to commit to it right out of the gate. And like we talked before about people taking a risk stratified approach, everyone starts in non-prod, get the easy wins, turn on the automation, and then they can run the agent in production and just only go in and take the ones which are really egregious and do them manually every now and then. So we have the goal, the schedule, the automation. And then the final thing, or one of the final things which people often care a lot about is setting guardrails for the machine learning. So for CPU requests and limits, what are the minimum and maximum allowed values? And should we even be setting limits? So we support a wide variety of different use cases for limits, not setting limits but never reducing them, setting limits but never increasing them, letting the limits go up and down with requests, but having a minimum value. And it's just because while requests have like a very well-defined, everyone should be setting requests, and it has like a well-defined, easy to understand use case, we see a much more flexibility with how people use limits.
Yeah.
And then,
No, I was just acknowledging that, yes, usually when you do a lot of requests, that's where you start paying the most in the mistakes.
Sure. Exactly, which is why requests is the focus, but then there are a variety of ways people want to use limits, and we support basically anything you could want to do, which was a little painful on our end, but important because, again, when people adopt tools, they want it to work for them and to have all of the flexibility they need. And then the final section, the HPA. When we detect that the HPA's a workload has a HPA detected, this one doesn't. What we'll do is, one of the big reasons people don't use the VPA built into Kubernetes is it conflicts with the HPA. If you have the HPA trying to add replicas to reduce the utilization down to a target, and then the VPA trying to reduce the requests to get the same CPU utilization to go towards a different target, they fight each other and they thrash. Mm-hmm. So the way we work is we layer on top of the HPA and are compatible with it by patching the target utilization. And that lets us eliminate the waste without causing any change to the horizontal or sort of scaling behavior. And then you're also able to set minimums and maximums on the target utilization. Again, going down to how do I set guardrails and make sure the machine learning is doing what I want it to do.
So when you mean that you work alongside, on top of the HPA, it means that the HPA takes precedence and then you work on it, or vice versa?
So the HPA will be running 24/7, adding and removing replicas. I think by default, it's checking every 30 seconds. We, as you saw from the schedule, will only make changes once a day, once a week, whatever you tell us to do. Okay. So what we will do is we'll come in once a day, we'll right-size the pods, configure the HPA to work with the new pod configurations, and then step back. And then for the rest of the next 24 hours, the HPA does its thing, adding and removing replicas as needed. And then we come in again a day later and make maybe a small adjustment, maybe not if it's not necessary. But the HPA takes precedence and is the one which is making ongoing decisions. And then we come in every now and then and give it a nudge.
Oh, I see. Actually, now that looking at the demo, something that came to my mind, and correct me if this is something that it makes no sense, but something that I struggled before is with when I'm installing something out of Artifact Hub. Like, for example, like Harbor. I want to store Harbor. I know that they come with some requests and limits that they suggest, but it is hard for me, for those third-party solutions that I'm installing, to figure it out what actually they need. So this could be perfect for me to I know that at least it will be washing not only my workload, but also all these workloads that I'm bringing in, and give me the right sizing that I should use for them. Is that a good assumption?
Yeah, that's a great example. And one thing we typically see third-party tools install is daemon sets. And another dirty secret is if you start pulling daemon sets in left, right, and center, you can end up with the overhead on each node from just the daemon sets is 25-30%. So right sizing those, we typically see is something people prioritize because most workloads are running 2 or 3 replicas, even if they're in a huge cluster. Daemon sets are running 1 replica per node. So you get these very, very large numbers of replicas, which again adds up to, if each of those replicas is inefficient, can add up to a lot of waste. So yeah, it's a great example.
Okay, interesting. And so something that you mentioned that I want to kind of like bring back again, because I think is powerful, is the fact that the tool helps you, it fits basically your own, I'll say, strategy, because you can just start by, all right, so let me turn it in, but I'm not going to put it in autopilot. I'm just going to first watch it. I want to see what's going on. I want to see how much I'm wasting. I want to see my money go up for like maybe like week or 2. And then as I see that applying the patches manually, if I see a performance, the performance is not impact, but actually I'm saving money, then I can get to the point where, okay, go ahead, autopilot, because I trust this. So I like that strategy that I can just use it as I need it. So this is actually great. And I know every tool that I've seen have that capability where it's either all, okay, go ahead and auto apply, or you have to do it always manually.
Exactly, 100%. And we deliberately designed it to be easy adopt in that sort of fashion, where you can sort of dip your toe in, look, see what the potential value is. You can do a few manually. You can wait a week. You can do it differently in non-prod versus production. The way we configure it, the way it's configured is all declaratively with annotations, etc. In the cluster, and you can set defaults. For different clusters. So you can say, okay, in non-prod clusters, do it automatically. In production clusters, don't do it automatically, or don't even have the applier. And that way, again, you can pick the low-hanging fruit, get comfortable with it, and then when you realize that it makes better decisions than developers were doing manually, or not doing manually, just taking whatever came in the box and never changing it, then people will sort of push it to higher level environments.
So another thing that I was noticing is like, because you provide the patch already, like what to apply, and I know a lot of people are going to ask, oh, what happened? I use GitOps. Yeah, because now it's the cool thing to use GitOps. But interesting that because you provide the whole patch, I could just copy that file, go to my GitOps, apply it, and then I can just get it done in that way.
So you 100% can do that. You 100% can do that. And that's why we provide the patches, so you have total flexibility, and we have people who do it that way. However, again, if you're running at scale, often the conversation we have is people say, okay, I want to check the patches into GitOps. And we're like, okay, so you're saying you want 20,000 PRs a day to make small adjustments to the requests. And that's like, well, actually, maybe not. So there's also another way you can do it where our applier will patch, and then you can configure the common GitOps tools to ignore conflicts. So with Argo CD, the way it works with managed fields, we patch the requests and limits. Kubernetes will say, okay, StormForge is the one managing these fields, and then you configure Argo to not trigger differences, syncs on fields managed by StormForge, and then you get all the benefits of both tools, and they don't fight each other. But it's a great point as well, because again, a key part of making it easy to adopt is making sure it plays well with all of the other tools you're using, which for most people is GitOps.
Oh no, I mean, definitely you're right. When you're working with so many workloads, you don't want to do that.
Oh yeah, some people do. Some people want to, but not everyone wants to. And then again, it's about providing the flexibility that people can make it work for their use case.
No, I love it, and I appreciate. Thank you for sharing the demo, because it gives clarity of what the tool does. And actually, I like the fact that the way that you explain it from the beginning, and now looking at the demo, is like it basically makes true the title of the podcast, which is like, there's not one size fits all, because you basically bring in the best out of Keda to solve one problem, the best out of Cap.17 to solve one problem, and then StormForge solving this other problem that is having the, let's call it the trifecta of our scaling and optimization.
Bingo, exactly.
Awesome.
I know our marketing team is going to clip that out and make a little short video of that.
Awesome. So we're gonna be getting towards the end. So we have this section where we ask some fun questions, kind of like to ease out, because we already have a lot covered, and I know that it's being very, very active. So we got about 3 questions that we want to ask you and see and get your answer. So let's go with the first one. So what's the most surprising thing you have automated in your life?
That's a good one. It's gonna make me feel old. A decade ago, when I started getting, actually more than a decade ago now, when I started getting into machine learning, it was just when neural networks, deep learning had sort of become the latest hot thing. And then the way it used to work is you would train the neural networks. There's these parameters, or there's these levers called hyperparameters, which control the size, the shape of the network, etc. And picking the right values manually is very difficult. And the way it used to work is people who are experts, who understand the architecture of the networks, would go in and be like, okay, I'm going to try 5 layers, each with 256 neurons. The optimization, there's an optimizer, there's the learning rate for the optimizer, different types of optimizers. There's all these different things you have to pick. And then, again, it's a very similar story to requests and limits. You can do it manually, but it can become very, very painful. And me and another coworker discovered that there was machine learning to pull these levers for you. So machine learning to tune the machine learning models. Then my friend had spent 3 months. He had spent 3 months training his model himself, and we used that as a test case. And I think within 3 days, machine learning had found a better configuration. And it's just because, again, a lot of these problems, it can be very hard to find the right values doing it yourself manually, very time consuming. And then having the machine learning pick them for you can be extremely effective. And requests and limits, it's not necessarily as complex as training a neural network. It's actually fairly basic. It's just having to do it thousands and thousands of times for different applications, which just becomes such a drag that it's just not something anyone wants to do manually.
And I want to just give you like a super kudos on that, because there was no such thing as MLOps back then.
No, but this is actually this hyperparameter optimization is now one of the things which grew into sort of one of the different planks of MLOps. We were just doing it a little bit earlier than maybe we were doing it a long time before there was a sort of a cool buzzword for it.
Awesome. Let's go to the next one, and let's see. We got here. If you had to explain Kubernetes to a 5-year-old, how will you do it?
I feel like this is a common question. Then I definitely feel a little bit more pressure on this one. What do people typically say?
They basically
I'm going to
say,
turn it around.
I don't know. It's like all crystal. I haven't tried with my 6-year-old yet, so I'm watching for your answer.
Did you buy the Kubernetes? Did you buy the Kubernetes children's book with the pictures and the animals? Actually,
I got all of them. That's
how you didn't just get the book, you got the animals.
I got the animals. That's how I explained to my youngest Maya, and I said like, so this is Phoebe, and it's a PHP application that couldn't fit on his own box, so he had to find out how to replicate himself and all that. So that's how I got to explain to her, but I supported that story a lot.
How did she understand it?
She told me, "Daddy, you're crazy."
I don't know if I have a better answer than that. I'm trying to think. This isn't something which comes up frequently.
Yeah, it doesn't. And by the way, in fairness, coming from the startup perspective, like everyone always asks you to explain your startup like a 5-year-old. But in fairness, is a 5-year-old gonna give me money? So I'm just putting out there. I'm sorry, I'm sometimes polemic on those type of questions. So.
No, it's totally fine.
Awesome. Let's go to the next one. And what's a fun fact about applied mathematics that most people don't know?
So the bit I like the most about applied maths is when people see it, they think of the equations, etc. But by far the most interesting, the most fun part of applied maths is the mathematical modeling part of it. So it's how you make assumptions to translate some sort of real world scenario into a set of equations, a model that you can then analyze, and then use those, and then take those as sort of outputs of the analysis and go back and check your assumptions, see if you can make some sort of prediction and do the reverse loop that you can then test, etc. But it's that translation between the real world and equations, which I think is the most interesting, fun part of it, and the bit people don't think of. Everyone thinks of differential equations, linear algebra, and all of the actual maths part of it, but the modeling part of it is basically the key and the most interesting part. And again, it's very, very similar to building a product, building a tool, building something like a platform for your company. It's less about the technical details about how it all works together and more about how you understand, okay, what use cases am I supporting? What do customers need? How do I build that? And then how do I make sure it works for them, etc. That translation between the technical details and the business case you're trying to solve for, etc. I always found the two very similar. And again, I think it's in the same way that mathematical modeling is the most interesting and the most useful part of applied maths, I would say the similar sort of product management, etc. How do you understand what your customers want? How do you build it and make sure it works for them, etc. I always saw a lot of similarities there. And again, wow. I think in the same way that the mathematical modeling is often overlooked, I think the product management side of it and making sure that you're not just building for the sake of it, but you're building to solve a real problem in a way that is well designed and will work for customers is basically the key.
Wow. I mean, actually that's amazing. I never thought of that way. So I just learned something new. Awesome.
Maybe it wasn't super fun, but maybe it was a fact.
No. Super fun because I mean, never thought of that way. Like, yes, that when you're modeling, definitely you simulating what a product owner manager is doing already. It's kind of understand. So no, I love that explanation. Actually, that's why I made a note because I want to keep it. It already helps me. I can go back to tell my customers like I'm modeling mathematics. That makes it super fun. Awesome. Hey, I know that we will be here hours talking about it, but before we wrap up, I would like to give you a final time to talk about StormForge because I think the way that you guys solve that problem is really, really smart, and I loved it. And thank you for taking the opportunity to show the demo. But my last question would be, and maybe just to wrap up, like if you have to explain StormForge for a CFO, for a CEO that might not be a fully understanding like what Kubernetes really does and the technical part of it, like what would be that 10-20 second pitch that like what am I getting with StormForge?
An easy way to save 50% on what you're spending on Kubernetes, which I think a CFO would love.
Oh, definitely. Definitely. Awesome, Jhon. But so we unfortunately had to wrap up. I really want to appreciate your time, Jhon, because this has been amazing, especially in the fact that you break down such a big problem that we all know is a fact in the Kubernetes, and also in the Kubernetes and cloud space, because even if you're running something outside Kubernetes, you're always going to face the same issues, like right sizing your workloads and making sure that you're not spending more than you should. And I love the fact that you explained it very clear. The fact that you brought up that trifecta and basically make it super clear. I appreciate your time. Thank you so much for making this happen. And anything that you want to add, or any place that you're going to be soon that people should go and see you?
Yeah. First, thanks for having me. It's been super fun. Second, I did a very short demo today, but most people, if you want to learn about a tool, you want to try it yourself. If you go to our website, we have a sandbox where you can play around with the product. That's what I was demoing out of. We have a free trial. You can sign up and try it for yourself. As I said before, the key part is making sure you're building the right product for people. I'm sure our product management managers will reach out if you try it. Please say yes and give them the feedback, because that's super valuable to us. And then I'll be talking about the same topics again at KCDDC and Kube Day Columbia in September and October. So if anyone's going to be there, come find me. We can dive into more details or talk about whatever people want.
And as I absolutely recommend it. I mean, we're gonna put all the information about the events in the description, because definitely, this is a problem, but the best part of it, there's already a solution for it. So, Jhon, thank you so much for your time.
Thanks, Angel.
We hope you found this podcast episode informative, engaging, and entertaining. We can't wait for you to join us again for our next episode, where we'll continue to explore the exciting world of cloud native and Kubernetes. Until then, keep exploring, learning, and making extraordinary things